Welcome, everybody. So, good morning. My name's Jason Luke. I'm the conference chair here today for our Trenchless CBS. I'm the national practice leader at Associated Engineering. And I'd like to welcome you to our virtual capacity building seminar. This is Associated Engineering's first ever live capacity building seminar. So we're going to do our best here, and just forgive us. There'll be some transitions and things, but we're going to do our best to put on a good show for everybody. Before we start, just want to make an announcement that I'm attending this capacity building seminar from Edmonton, and wish to acknowledge the land in which I'm speaking to you from is Treaty 6 territory, and is a traditional meeting ground and home for many Indigenous peoples, including the Cree, the Saulteaux, the Niitsitapi, Métis, and Nakota Sioux peoples. Since we are all on virtual platforms with staff, guests, and clients from across Canada and some from the US, I'd also like to acknowledge the Indigenous peoples of all the lands we are on today. AE has a culture of safety, and as such, I'd like to have a brief safety moment to discuss some home office safety. As you can see today, I am working and broadcasting from my home office. So let's just please remember that when we're working in our offices, just like we're just at our home offices, just like we're in our regular offices, make sure we make our work areas as ergonomic as possible, keep proper posture, get up regularly to move and stretch those legs, and to refocus rise every so often to prevent some eye strain. Also, just like in our offices, please keep the area safe from trips and navigational hazards that could lead to home injuries. The Trenchless Capacity and Building Seminar brings together staff from across Associated Engineering, and all of us are involved in trenchless projects of some sort. And we do this because we believe that knowledge sharing is key to maintaining our leadership and bringing the best solutions to our clients. We generally hold CBSs every year or two on various practices within Associated Engineering. Today is unique, as typically our CBSs are for internal staff, and we might invite a few local clients. And when we started putting the planning together for the CBS, we were planning to do this in Vancouver and to have this in person. And just due to COVID and everything else, we had to move to a virtual platform. And so generally, we typically it's just for staff, and we might invite a few local clients, and it's typically very low key. However, like today, this virtual platform has allowed us to bring together, our clients from across the country, and quite frankly, I'm overwhelmed by the response that we've received from the clients. And so I just really want to thank for all the clients who took time out of their day to be here today to join us. Our CBSs are not designed to be business development opportunities, but I just think with the COVID and everyone has had limited opportunities for professional development hours, I think that's what's kind of spurred on a lot of interest from our clients. So again, this is great, and we really appreciate you being here today. Today, we'll feature presentations on various AE projects from across the country, including from the Regional Municipality Wood Buffalo, City of Winnipeg, Metro Vancouver, Brampton, Halton Region, City of Calgary, and EPCOR, covering new installations, decision support, concept design, and rehabilitation. Some of you may know that this was a 2-day event. Some clients showed up yesterday, and it was, just from the invitation, it was kind of weird. But yeah, yesterday was just an AE staff. So we talked about some things in terms of design and some lessons learned, and then today was a little more general. So that's where we invited some clients, and quite honestly, I think initially started with about 40 people being invited, and I think we're well over 100. So that's excellent. So really pleased. Yesterday we had keynote speakers in each day. Yesterday we had Jim Geisbush, Central Arizona project. He was speaking about reliability on 550 kilometers of tunnels and aqueducts and canals that he monitors and he maintains in Arizona to serve water to over I think it was 80% of the population of Arizona. And then today, I got my former graduate professor, colleague, and friend, Dr. Sam Ariaratnam from Arizona State University, who will provide us a keynote today. And again, just in closing, I just want to thank Martin Jobke, our president, Chris Kronsky, our senior vice president of infrastructure, the general managers across the country, just for the support to put on this capacity building seminar. Audrey and Leanna, for the countless hours they did to kind of stitch everything together. Linda Chaco here helping with the organization. all the presenters that helped out and the last minute to put a lot of things together. So thanks very much for all the hard work, and that's what makes today possible and yesterday possible. So again, just want to thank everybody for attending. And now what I'd like to do is just welcome our President and CEO, Martin Chobke, to say a few words today. Martin?
Hi, Jason. Thanks. And again, thanks everyone for joining us this morning. And again, I would also like to acknowledge that I'm in Vancouver today and joining you from the territories of the Coast Salish peoples, including the territories of the Musqueam, Squamish, and Tsleil-Waututh nations. I also want to acknowledge and extend my appreciation to all the Indigenous peoples and all the lands that we are representing here today. As Jason mentioned, it's taken a lot of people to put this together, and it's actually quite exciting in terms of doing this for the very first time. Quite interested to see in terms of where we end up in terms of attendance today. We were definitely seeing a lot of interest from across the country and literally from across North America. So again, thank you very much for everybody for making time for us this morning. I've no doubt it was as part of the sessions yesterday, there was a lot of good conversation. We hope that the presentation spur discussions and offer valuable takeaways, not only for our staff, but also for those that are joining us that are our clients and other individuals and organizations that we work with. The moderators and speakers will basically take you through the day. The chats, I think, are a very important part of this process. And again, would definitely encourage people to get involved in terms of the chats. The polls will be interesting. They're always a good way to break things up. So to all of you for taking the time to spend with us today, thank you. And I very much hope that you enjoy the virtual seminar. I suspect this is going to be somewhat of a new normal for us going forward, at least for the next 6 to 12 months. So to everyone today, stay safe, stay healthy. And again, thank you very much for joining us. Back to you, Jason. Thank you.
Awesome. Thank you, Martin. Sam, if you can address and put the slide forward. All right. So today, I'm again very honored and excited to bring Dr. Sam Ariaratnam as our keynote speaker today. He'll be speaking about some litigation things and just some of his views on the trenchless industry. I've known Sam for a while. And again, like he was my graduate professor, and then we worked together at Arizona State University. And then he's a friend as well. I've known him for, I don't know, a long time. Anyways, so Dr. Sam Ariaratnam is professor and chair of construction engineering at Arizona State University with over 24 years of experience in trenchless engineering research and education. Prior to joining ASU in 2001, he was a faculty member in the Department of Civil and Environmental Engineering at the University of Alberta from 1996 to 2001. He received his Bachelor's of Science from civil engineering from the University of Waterloo, and his Master's of Science and PhD from the University of Illinois in Urbana-Champaign. Dr. Ariaratnam has published over 300 technical papers and reports and is a co-holder of 5 patents. He served as the chair of the International Society for Trenchless Technology from 2010 to 2013, and was the chair of the ASE Pipeline Division from 2017 to 2019. He's a past recipient of the ASE John O. Bickle Award, Arthur M. Wellington Prize, and the Pipeline Division Award of Excellence. He was elected as a Fellow of American Society of Civil Engineering in 2015. Dr. Ariaratnam is also a Fellow of the Canadian Academy of Engineering and the U.S. National Academy of Construction. He is actively engaged in consulting activities on trenchless projects for various clients in Canada, Brazil, Hong Kong, mainland China, New Zealand, and the United States. He's a registered engineer in Arizona and the province of Ontario. Very great. Thank you, Sam, for being here today, and I'm going to hand it over to you.
Great. Thank you, Jason, and all of you. And I looked at the list of people here, and it's great to see people from all over my homeland of Canada. But today I'm going to give you kind of a perspective on risk and litigation, kind of issues with trenchless design and construction, tying both of those together. And in the U.S., it is quite a litigious society. So I'll give you some insights into that. I get involved with a lot of claims and expert witness type things that go on with trenchless. Sometimes it's in the design perspective. Sometimes it's in the construction aspects of it. So what is going on right now? And if you look at society, and Canada is no different, the urban centers, today, 55% of the world's population live in a city, right? And that's anywhere in the world. In Canada, I looked it up, and it was about 81.5% of people live in cities in Canada, and that's about where we are at the U.S. as well too. About 82% of all people in the U.S. live in a city, and this figure, from a worldwide perspective, by the year 2050, is expected to increase to about 68%. As people are moving to urban centers looking for employment opportunities, so we're starting to build these bigger cities. If you go to mainland China, they have what we call these mega cities. Those are cities of greater than 10 million populations. I mean, there's some cities that have 30 million people that live in the area, and so all of our infrastructure systems have to grow. I mean, we've got to get our utilities out to these people, our roads and bridges. Our transportation networks are huge, with a lot of people like subway trains to make use of underground space for those types of things. And so as a result, those of us that are involved in the infrastructure industry are going to have a lot of work in the foreseeable future that will continue to go as we grow our populations and people moving to these cities. When we look at urban infrastructure, in where we are today, it took about 5,000 years, and we're expected to double this infrastructure over the next 35 to 40 years through construction and that. And from a design perspective, these systems, minimally need to last more than 50 years. So we have to try to be creative in terms of how we do that. And today I'm obviously talking about trenchless technologies and underground infrastructure, utilities, those types of things that we need to look at. And a lot of our systems are aging. We have old pipes. We have a lot of places where we've got cast iron pipe that we're changing over to ductile iron pipe. We've got a lot of concrete, clay pipe, these types of things that are in various stages of their life cycle, and we need to upgrade all of those. Not only that, but we have capacity issues in that, and so trenchless technologies like pipe bursting are very important to be able to upsize the capacity. I mean, when we build a new subdivision and we're tying it into an existing system, I mean, it can't handle that kind of waste and all that, so our products. So we need to upsize those and build new ones. And so what do we look at? And so trenchless technologies, but there's a lot of owners out today and out there. And from an owner perspective, you're looking at, well, is it economically viable? What does it cost? Can we do that? I mean, is trenchless, we look at our natural resource conservations these days. We're coming more and more looking at the whole aspects of sustainability and will these technologies be better on our natural resources? The social responsibilities as well, making sure that we have minimal disruption to surface activities and the general public, which is paramount to what we do in any kind of application in that. And then when it's operational, what is our efficiency in our operation of those systems? I mean, the process, the technologies, the people that are involved in this, how does it work? And trenchless really has a global following. I mean, we're not just using it in Canada and the US, it's all over the world. And when I was chair of the International Society, I oversaw trenchless activities in 40 different countries. And so I spent half my time on United Airlines, traveling to many places to see and talk to governments and see what they're doing. And this is just a snapshot of the global aspects of it. I mean, you can look at Johannesburg, South Africa. This is New York, Madison Avenue, doing a lining job. Sydney, Australia, and of course Paris is with the iconic Eiffel Tower in the background, is a microtunneling project across the Seine River. Mainland China. So that picture of mainland China is a rig from China National Petroleum, and they did a 3.3 kilometer shot, not just one, but three 3.3 kilometer shots beside each other underneath the Yangtze River for oil and natural gas type products. So both of them. Abu Dhabi. Sometimes we're doing trenchless in the middle of the desert, but and then Germany with this direct pipe. And I understand you'll be talking about direct pipe, which has really become more and more popular in as a tool in the trenchless toolbox. Well, as we all know, today we're in the world of COVID, and so we have to take precautions. And so where are we with trenchless with COVID? Well, I can tell you that as much as COVID has been a very negative from a health and a human aspect of it, one of the things that has come out is that we're doing a lot more remote working, and our kids are in school remotely. My kids at Arizona State University, I do teach live, but I have maybe 1 or 2 students that'll show up to class, and then the rest of them are all remotely. But we found that there's a lack of our IT infrastructure, and you see a lot of directional drills and trenchless applications for installing new telecom systems. Our 5G, it's a big race, and I can drive outside today, and I'll probably see 3 or 4 horizontal directional drilling rigs here in the Phoenix area that are putting in telecom systems to upgrade that infrastructure system for telecommunications. But trenches has been a boom. I was on a call yesterday with one of the big manufacturers of drills, and they're having record years. They're as an industry, it hasn't slowed down at all. I field calls weekly for engineering firms and also from contractors that are looking for talent for their jobs, because they just don't have enough manpower to handle all the work. And this is a global thing as well too. It's not just Canada and the US, but it's all over the world. So we are seeing that this COVID hasn't really stopped or slowed down what we're doing in terms of trenchless activities. However, we have to be more cautious in that. And just to give you a little perspective of, Canada and the US, and you've read a lot in the news about how, the US has handled it a little bit differently than Canada. Well, social distances are a little bit different. The top boat is the American boat in Niagara Falls, and the bottom boat is the Canadian boat. So you can see which country is taking social distancing to a different level. So HDD in Arizona versus Alberta, for example, or the northern states. I mean, you've got, we have sunshine and that every day, so it's a little bit different in terms of the work. And then, of course, the winter that's coming up right now in the northern area and part of Alberta. So cold weather HDD can be a lot different to deal with. We do a lot of this HDD even on campuses of universities and that. This is a telecom. This was before COVID, and this is looking outside of my building at the university, and you can see they're installing a Cox communication systems around campus and around the area to continue doing it. And you can see how minimal disruption is with HDD. And so universities and public institutions are doing a lot of trenchless. We do lining on campuses and things like that as well too. I want to show this picture to really show the benefit in the nation's capital, the US, of trenchless. And this is actually a water line that was being installed at the Washington Mall. And any of you that get a chance to go to Washington, D.C., this is where all the Smithsonian Institutes are, the Air and Space Museum, all of these things. And so there's no way that you could dig this up. And so we had to look at a trenchless option in that. And actually, this job was a very successful job. And you can see the tourists are still operating. And I actually arranged a trip for congressional staffers from the US government to actually come out one day. And I flew out to DC and we talked about this so that, at least Congress can understand more about directional drilling and trenchless, and how trenchless as a whole have a lot of benefits to society, because there's still a lot of people that don't really understand trenchless technologies and how these can really help with infrastructure and make life a lot easier. But, we use it all over. This is, I guess we have this election coming up, but this is an HDD project right at the White House where President Trump lives. And we do use these in all different situations and that. So I thought this was kind of an interesting picture. I can't really tell you what the application is but it's all secretive, but interesting projects as well too. Here's a couple of young Alberta guys. You might recognize the one in the middle, but this was taken almost 20 years ago to the day, right? And this is just in Nisku, south of Edmonton. It was a 660,000 pound HDD machine doing about 3,000 feet of water line. And so you see that all of these guys are been involved and from a long time ago. So Well, what can possibly go wrong? I mean, trenchless, yeah, what can happen? Well, these are all pictures of inadvertent returns or hydrofractures that have occurred with horizontal directional drilling. I mean, it's underneath a road, and all of a sudden you have a release of drilling fluids, and this can happen. So, proper design, proper construction practices can really avoid this, because this is a litigation just waiting to happen right here in terms of application. And so, is it the design? Is it the way the contractor drilled? What is it that could have happened right there? You know, I can't stress enough in any of trenchless, and this is related to horizontal directional drilling, but soils investigations obviously are where we need to start with any kind of trenchless operations and that. And I know I preach to a lot of owners and engineers that it's so critical to have that information prior to even at the design stage, to know, where, what depth should we be designing it to? Should we get out of cobbles and gravels if we're doing HDD, get out of rock if we're doing pipe ramming? What kind of soil conditions are really appropriate for whatever trenchless method we're doing? And so having enough soil borings are really, really critical. Or doing other types of investigations. We do geophysical investigations, many different things that could be applicable. Sometimes with whatever planning we do, we sometimes can get a little bit off target, and this is a true picture of an HDD contractor who went just a little bit off target and went into this building and drilled into it. And fortunately, nobody was hurt during this. Another thing that I tell contractors is you should be really careful in what you name your company, because the company that did this job, their name was Direct Hit. So got to be careful of how you name it. Striking of utilities, and what gets a lot of attention are natural gas lines. When you hit a natural gas line, and I'm actually involved in most of the natural gas explosions and that happen in the United States. I represent the gas industry, so I work with a lot of different gas companies. The bigger picture here, the information about JJ's explosion, that was a case in Kansas City where a contractor was drilling for putting in a Time Warner telecom cable, and they hit a 2-inch gas line that blew up a restaurant, and it unfortunately it killed a young lady at the restaurant who was a worker, but there were 16 injuries that occurred. It destroyed the entire restaurant, and so it was quite a big case that happened down in the States, and I was involved with it, and there was a lot of issues with that, and the contractor just didn't do their due diligence in terms of locating existing utilities during the installation. These other two cases are ongoing. I'm involved in both of those. One of them is, the top one was in Sun Prairie, Wisconsin, and it blew up a shop, a store, and actually one of the firefighters died during that explosion. Similar type situation, and the one on the bottom is in Durham, North Carolina. And in this particular case, a contractor was drilling a telecom line underneath a sidewalk, and knew that there was a gas line, a service line going into a coffee shop, because you could see from the gas meter. But they said, "Wow, it'd be too much to core out and try to expose it, so we're not going to hit that 3/4-inch line." So they figured they'll just drill and hope in a prayer. And sure enough, they hit it. It blew up the coffee shop. It killed the owner, and then one of the gas company guys was killed in the explosion too when they smelled gas and got there. There's over $100 million in property damage, because immediately adjacent to that coffee shop was the largest private collection of antique Porsches in the world, and there was about 55 or 60 Porsches that were in that. And all but 3 of them were destroyed, including one that had just had an offer from comedian Jay Leno for $8 million to purchase it. So it could have totally been avoided. There were, I said, two deaths. There's 25 injuries, and an injury in a gas explosion is pretty serious. There are comas and body parts that were damaged during that. So these are things that can happen if construction practices aren't followed when trenchless activities are being done. If you follow proper practices and proper procedures, you're not going to have these situations, or the likelihood of this happening, unless it's an abandoned utility that you didn't know of, are very, very small. There's a couple more pictures of different cases where horizontal directional drilling has hit gas lines and caused this explosions to occur. I mean, do they hit lines? Sure they do, but a water line you'll know because the road will be gone. A sewer line, possibly similar things, and that. But an electrical line, we have electrical strike detection systems that'll tell you. It's the gas lines that are the problems that we have to be careful of in that. So, can even a monkey operate a directional drill rig? Absolutely not. It's not the case of just anybody jumping on a rig or any piece of trenchless equipment. I focus on directional drilling because that's what I do most of my education and research on is in HDD technologies. But you can apply that to any trenchless method. You can't just jump on a machine and start operating it. Just like you can turn on a car, but if you don't know the rules of the road, you can't drive a car, right? My 12-year-old son can turn on a car, but he can't drive. So similarly, and if anyone's interested, this picture was taken in Thailand of a bunch of monkeys that were curious of what this yellow thing was in the middle of their area. Professional training is really critical, and some of it is hands-on field training, and some of this are in classrooms, and these are all directional drilling training courses. There's also lots of training courses that are available for all different types of trenchless methods. So if you're doing microtunneling, there are training courses for that. And from an engineer perspective, and even from a contractor perspective, I think it's important to get to understand the design aspects of it, understand the geotechnical, the importance of that, and even just how does it work? How does the various trenchless technologies work and operate? So this class right there, with all the people on the right hand side, are one of the ones that I give with people here in Arizona, and there's about 120 people or so, and half of them are contractors that are coming to learn about engineering aspects as well as just general aspects of trenchless, and the rest of them are engineers and manufacturers and other people within the industry in that. Can't stress enough training. I mean, like it says here, not everyone needs a $160,000 rig. They need $10,000 rig and $150,000 in lessons, because that's what it's about. It's really understanding whatever technology you're doing. And it doesn't matter what the equipment is. You can have the best equipment out there, but if you don't know what you're doing, then you're going to run into situations that like this situation out there as well. So contractors, we bind them to things like good practices and a couple. I mean, there's a couple of books out there. One is the Common Ground Alliance, which talks about utility practices, things like that. And then NASTT's Horizontal Directional Drilling Good Practices Guidelines. Myself and Dr. David Bennett are two of the co-authors of this book. And Dr. Jason Luke has given plenty of these courses related to that book as well, too. And why I point these out is that when we get into litigation cases, those two documents there get brought into litigation. And this kind of the good practices to follow are in both of those books. And we talk about those. And from a legal perspective, they stand up. In several states here in the US, they point to the Horizontal Directional Drilling Good Practices Guidelines as the standard of care for directional drilling. Say if you're directional drilling in the state of Pennsylvania, you need to follow what's in that book, or in Georgia or in other states, you need to follow that. And Arizona as well, too. So very important that contractors look at those things. And it's not a bad thing for designers or engineers or owners to also attend courses or read books related to that. And it's not just horizontal directional drilling. I mean, NASTT has a suite of books related to microtunneling and pipe jacking and other kinds of things, as do the American Society of Civil Engineers Pipeline Division. Yesterday's speaker, Jim Geisbush, is the current chair, and Dr. Jason Luke is the vice chair of that right now. And they have a lot of manual practices as well that are also cited in litigation cases. So do your homework and look at what's the current state of practice in whatever trenchless activity that you're engaged in, whether you're a designer or whether you're a contractor, because there's a lot of good information that all of these types of books and that can provide to you as well. You know, people say, oh, well, sometimes we can't pothole because we're in concrete or asphalt or whatever. Well, you can. You can do coring, and this is a great example of competent contractors who are coring legally. They're crossing other utilities and they're coring down to identify, creating a window to identify where exactly those existing utilities are. Because, you know, we all know that you know, it's a general practice, don't rely on as-built drawings because there's a lot of discrepancies and errors in as-built drawings. So you need to call your locates and then verify those utilities and where they are. I think it's also a good idea as design engineers to have these utilities located as well prior to your design, because then you know exactly where those utilities are and you can do a better and more competent design. I mean, what you don't want to happen is you just design a line and then put it out to bid. Contractor gets out there, they're doing the utility locates, and they find out that the design is intersecting or too close to some existing utility. So if you do all that, that's part of the pre-construction or pre-design aspects of it, can really, really be good to do as well. So as a designer, you've got to understand, you know, doing your calculations, whether it's pull loads for horizontal directional drilling or jacking loads for microtunneling or any kind of jacking operation, your IRs or your inadvertent returns. You can do these, you know, we call them frac out calculations. You can calculate your maximum allowable downhole pressures based on your soil conditions and your depths and your diameters and all of those types of things. So as a designer, and also looking at your minimum bend radius and those aspects of it, as a designer perspective. From a geotechnical engineering perspective, been on plenty of projects where they use geophysical surveys as well as soil borings, those critical projects like that, where you want to make sure that you have as much information of what's underground. And when you're doing those soil borings, and unfortunately I've seen them, if you're you know, 20 meters deep, you don't want to do a soil boring that's 10 meters. You've got to go to that plus some, right? So we always recommend you exceed whatever the design depth is in that. But unfortunately, I do see that happening where they fall short of where the design depth is, and things can change a lot in those soil lenses as well. Geologists I put in there, and you know, geologists can provide a very interesting perspective of the history of the area. And if you ever talked, and some of you might be geologists, but you really understand, you know, how things were formed through, you know, volcanic shifting of the area and that can really give you some other information on what's the area was like. I was involved in a claim last year in Auckland, New Zealand, or actually south of Auckland. And what had happened, they were doing a horizontal directional drilling underneath the water body, and the drill, when they were drilling, they hit a 53,000-year-old tortora tree. I said, well, how do you know it was 53,000 years old? And they said, well, they did carbon dating. So, you know, that is so petrified, right? It's like harder than rock. And one of the things that was brought up was, hey, you know what? A geologist would have told you that in this area, we had all kinds of formations and aspects like that were involved in it. But obviously, that was a showstopper when you hit a 53,000-year-old tree and lose your tooling and that. Risk assessment. I'm a big believer in risk assessment. I think that any of these you know, significant projects, and even the small projects, do a windshield or do some sort of risk assessment of what the area is that you're going to be working in. But on the bigger projects and that, you know, you can have, you need to make sure you have things like an inadvertent return mitigation plan, right? Ask the contractor for that. Now, what's your mitigation plan if you do have a frac out or an inadvertent return? I want to know what your plan is. Do you have straw bales or sandbags or vac trucks or things like that on site with you if there were to have some sort of a release of drilling fluids in your project? And of course, subsurface utility engineering is becoming more and more prevalent. We're seeing a lot more, like I said before, in the design aspects of it as well, doing that pre-design so that we actually know what we're trying to design in, what kind of environment in that. So things like vacuum excavation, which is very common, and most contractors have vac trucks around. And you could even go to ground penetrating radar as kind of backup. And there are other electromagnetics and things like that that people use as well to try to classify and understand where the subsurface utility engineering. And American Society of Civil Engineers has a really good standard on documentation on subsurface utility engineering and different levels and what you would do in the various levels of that. I'm a firm believer that experience is really critical for design success in that. And so what I mean by that is really we don't do ourselves justice by having designers design projects that don't understand what the project is about. You've got to understand what you're designing. And back in the day when I first got involved in horizontal directional drilling, the people that designed HDD projects, they understood. I mean, when they saw the values, they could understand that whether the values made sense or not, right? And unfortunately, today, with much more increase in trenchless activities, we tend to have very good engineers that are designing. However, they really don't have that field experience or really understand if this pull load does that make sense, or does it make sense the maximum allowable pressures, or just even the design path. And so that's where we kind of can get into trouble sometimes with litigation issues from a designer perspective. You do a design, and unfortunately, some engineers end up relying too much on some of these so-called black box solutions, where you just plug in some numbers and you come up with a solution and don't really understand what they mean. And that can be a problem. And I'll give you a great example. So I'm a consultant for a company called Energy Transfer Partners, which is Sunoco Pipelines. And many of you probably have heard of the Dakota Access Pipeline in North South Dakota, where there was a lot of protesters and native lands and all that kind of things. Well, that was Sunoco, or Energy Transfer's line, liquefied natural gas line. Well, their next project, which I'm involved with, is called the Mariner East 2, and it's 350 miles or over 560 kilometers of 16-inch, 20-inch liquefied gas lines across the entire state of Pennsylvania. And so there's a lot of directional drills on that being done, like 300 plus HDDs underneath, in the community and all over. And of course, it just has lawsuits after lawsuits after lawsuits of people who don't like energy and directional drilling. Well, unfortunately, Sunoco hired an engineering firm that really is not a HDD or a trenchless engineering firm. They were just good guys, but and when they designed the project, they didn't know the difference between horizontal directional drilling and auger boring. And so when they designed the depth of cover, they designed it based on auger boring, which is a completely different operation than HDD. And so you had a lot of inadvertent returns on the project. As a result, I mean, this project has over $12 million in fines, but it's an over $3 billion project. So I mean, it's just a kick in the bucket. But as a result, there's been a lot of different litigations related to that. And they had to redesign because of that. But that's an example of designers that really didn't understand what they were designing. And that's a pretty fatal error in terms of that. And so all these had to be redesigned, a lot of them, and to go forward with that. I mean, I just testified in trial 2 weeks ago in one of the other lawsuits related to that big project, but just keeps happening. And it's because people are worried about drilling fluid getting into their groundwater and all kinds of things like that. Some things don't make sense. I mean, you guys should never complain about the long lines at Tim Hortons, because this is a long line at a Krispy Kreme donut here in the U.S. And I mean, that's ridiculous. The number of cars waiting for a donut. Specifications for HDD work, and this is another aspect that you've got to be careful of when you're looking at litigation and that. Unfortunately, this cut and paste method, we keep reusing specifications with wrong applications, and so you tend to be a little overly conservative sometimes in them. You ask for documentation that really is not necessary on a project, and you need to modify whatever specification to suit your agency and your project. A specification for a telecom project is going to be different than a river crossing of a oil or gas line. And so you can't just do cut and paste on that. Some of the issues with ineffective specifications, it's going to increase your project cost. You have claims and all kinds of things with that. It decreases competition, because some contractors, the good prudent contractors, will look at your specification and say, I'm not touching that with a 10-foot pole. And then you're going to get some desperate contractor that would bid on that project and really doesn't understand and will say, you know what, we'll make it happen. And then you're going to end up with all kinds of claims and costly litigation that could occur because of that. I mean, overly burdensome, and the legal exposure is not something that anybody wants to have. Whether you're a designer or you're a contractor, you want to avoid legal exposure as much as you can. And of course, deceptive bidding practices. A contractor saying, yeah, I know these specifications are wrong, I'm just going to bid on it, and then I'm going to have a change order. Right? That's what they're going to do. And of course, that ends up stifling industry growth, because it could have maybe an owner has a bad taste in their mouth because of a prior project that had happened. And so, this one, many of you might have seen this one, but I still love this one, the original contract versus the change order, right? And that's sometimes what can happen on these types of projects if they're not have proper specs in that. I want to show you an ineffective specification, right? This is an example of a project. And if you look at Quality Assurance B, contractor performing horizontal directional drilling shall have the following qualifications. And, on the surface, it looks good. Experience with at least 3 projects of similar time. I'm fine with that. Experience with at least 3 projects using downhole pressure tools, to monitor those downhole pressures. At least 3 projects requiring pipe buoyancy control, which is we fill the pipe with water typically when we're crossing a water body, just to help with buoyancy control. Experience with the use of a pressure probe. And then it says here, owns and operates a 300,000-pound minimum pullback machine and drilling fluid pumps, and then of course supervisor and all that. So you look at that and you say, wow, that's a pretty good specification. But it's got to be applied to the project. This project was to install 424 linear feet of 8-inch water pipe in an urban setting. There's absolutely no need for you would never use a 300,000-pound machine. You don't need that mud pumping capacities. You don't need to have pressure probes and all these kind of things for a project like that. And so, in my opinion, the engineering firm that did that, that's negligence on behalf of a professional engineer to put a specification like that, because all that engineer did was took a good documents from a pipeline type project and applied it to this 8-inch water line. And so, but this really did happen in the Chicago area in a project in that. Here's another one. If a release occurs within a wetland or a water body, a release of drilling fluid, reasonable actions within the limitation of directional drilling technology and the contractor's ability shall be taken to reestablish drilling mud circulation. That's what it said. But what constitutes reasonable action, right? From a contractor, they're thinking of modifying their drilling fluid and trying to reestablish circulation and continue, right, as quickly as possible. But an owner might look at it as, well, we got to cease pumping of all drilling fluid. We need to stop this returns from occurring, and we want to pull the product back to back to the point where the drilling fluid can be reestablished. 2 different things, but that's what the specification says. the intent of the language must be clear, right? And so you've got to make sure when you're looking at whatever you're doing that it makes sense in that, because people are going to read it literally. And that's why with the specification, it's got to be crystal clear in what you're doing. Here's one. At the top, they're talking about after successfully reaming borehole to the required diameter and pulling the pipe through in that. And then in the same, they say, in the event of a drilling fluid fracture, inadvertent returns or returns loss occurs during drilling operations, the contractor shall cease operations immediately. So what it's telling me is that when I'm drilling, if I have an inadvertent return, I got to stop right away. Well, what if there's a frac out during the pullback? Should the contractor just continue going? Because it doesn't talk about pullback. It says drilling operations. And so I know what they meant. I think they meant to say that during drilling and pullback operations should cease operations immediately, but they just said drilling and they were using it as an overarching term. But the contractor is going to look at it literally like, well, I was drilling forward, I didn't have a frac out, I started pulling my product and I had a frac out. Oh, I guess they don't care, I'll just continue going. So that's something to really consider. So what are elements of an effective specification? And here's a HDD specification in Arizona. I was actually involved in writing this specification with another colleague and some other industry people. And so if you do directional drilling in Arizona, you're going to have to follow these specs. But it clearly communicates the expectations. What are you going to do? It has a definition of what the terms are, relevant to the work being performed. So we actually classify it if you're based on a small, medium, and large rig. So, and that depends on the diameter and the length of the project in that. So if you're doing a crossing with a long length, then yes, have an inadvertent return plan and have pullback calculations. But if I'm doing 60 meters or 70 meters of a small telecom conduit, well, I don't need to do all that. That's not really necessary to do. So we classify that in a table within the specifications that states, based on those parameters, these are the things that the contractors need to use. So it's a single spec that can be used for any kind of horizontal directional drilling, and that eliminates that cut and paste issue that promotes safe working practices, and you want to reduce costs and the volatility of bid pricing and effectively mitigate risks in that. I mean, that's available. If anybody's, you just go to the Maricopa Association of Governments website and look for Section 608, horizontal directional drilling, and feel free to look at it and use it in any way or modify it to your projects if you wish. I talked about litigation. When I was still living in Edmonton, I was involved in this particular lawsuit. I was flying from Edmonton down to Texas on this, and this was back in 2000, so almost 20 years to the day almost when it actually happened. But this is what happened. It was I represented telecom giant AT&T. And they were in a litigation against another company called Quest, which is now called CenturyLink. And this is a big fiber optics boom that was going on in the late 1990s and early 2000s. And AT&T line was there, and Quest contractor drilled, and they hit the AT&T line. Then they continued to set up again, and they drilled, and they hit another line. And so it went to litigation, and it was a jury trial that I testified in. And the actual damages to the line were 1.2 million US dollars. That was easy to do. You could calculate, how to do it. But the jury awarded an additional $350 million to AT&T for what they call loss of use provision. So they said, well, they were negligent, and I was actually there to demonstrate gross negligence on the part of Quest, and that's what I did to the jury. I made presentations in that. Unfortunately, I just got paid hourly. I should have gone for a portion of the settlement, but regardless, litigation can be very costly. So when contractors, they might be doing a small telecom job, but you hit another cable, and you're talking about loss of use as a big thing. And so for the last 20 years now, I've been the expert for a company called Verizon, the telecom company Verizon here in the U.S. And they used to be called MCI WorldCom, now Verizon. So I actually work on all their litigation cases where an HDD is involved, where another contractor is drilling something and hits a Verizon line and does things like that. So I just actually did a deposition about 3 weeks ago on a case in Palo Alto, California related to that, because it's the loss of use that's the big thing that they look at, because the customers that are out of service or the businesses that are out of service because of negligence on the part of another contractor. But research advances the science, and you might recommend Dr. Luke and all these pictures, but we did a lot of work when I was at Alberta, and all these students and people involved in it. We did a lot of things to really advance trenchless, and particularly horizontal directional drilling and pipe bursting, and much of this work that was a preliminary work back in the early 1990s, mid to early 1990s. Other researchers all over the world now are doing more work in it, and I'm really happy to see that research and tying with industry have been continually going on, and we're just doing a lot more things with these technologies in that. I wanted to show you this. It's the largest HDD rig in the world, and this has a thrust pullback of 4 million pounds. And when you think about it, most of the rigs that you'll see that are doing jobs around here would be in North America. They're going to be about 1.3 or 1.4 million pounds of thrust pullback. The Chinese, this is a Chinese rig. They had a rig that was 2 million. A company a couple of years ago had a 2 million pound machine, but this is a 4 million pound machine that, as we're speaking today, is doing an installation in Fujian province in mainland China. And I actually have a research team that's out on the job site collecting data and looking at this project. I would be there if it wasn't for this COVID situation, but it's interesting to see that we're going to these larger rigs. When I got involved in HDD in 1996, around that time, the longest projects were like 6,000 feet. Well, the world record was done just a couple of years ago in Hong Kong. It was an expansion of the Hong Kong International Airport with another runway. And so they had to put in not one, but 2 jet fuel lines, 400 millimeter jet fuel lines to that airport. And they did a distance of 5.2 kilometers, which is over 17,000 feet, which is incredible when you think about how far we've gone. So we jumped from the world record of 3.3 kilometers, which was done in the Houston Ship Channel and in China, in the Yangtze River, to this Hong Kong project of 5.22 kilometers. And that's a lot of engineering, a lot of design that's involved in it to actually have a project like that under fruition. Black & Veatch was the design engineer on that particular project. And right now there are projects that are being designed that are looking at over 6 kilometers of HDD, and they are. And it's the science and the engineering that's really enabling us to continue on and doing things like that. I just wanted to kind of end with one of our secretaries. She had a great application for recycling of used triclone drill bits. Her kids are in the industry, and she made a table for her backyard using 3 tricone drill bits that had been used up. So I would love to have a table like that in my house. So just some concluding thoughts. Litigation may be avoided by proper design from an engineering perspective and construction from a contractor. So we have to have both of them aligned to really have a good, successful project without having litigation, which is the goal of any kind of trenchless project. Training and education of all parties. It's not just the contractor, it's not just the engineer. They need to all be trained and have an understanding. And a good thing to do with your young engineers is to take those people out to a trenchless site. If you're doing lining, have them go out there and spend some time watching lining process being done. If they're doing directional drilling or pipe bursting or direct pipe or whatever they might be looking at, get them to actually visually see that. I think that's really critical to look at that. Prudent pre-engineering activities, as I discussed, is going to significantly reduce project risks and litigation. If you follow these good practices, you should have less chance of having any kind of problem go wrong in your project. And of course, one of my pet peeves are poorly written specifications. They're confusing and often call for nonsensical requirements. Like I said, they're just putting a tellus line in. You don't need to do pullback calculations and frac out calculations for something like that. So with that, I'd like to thank you very much. And there's all my contact information, my phone, my email, website, my LinkedIn, and my WeChat account in that. So if any of you anytime want to get a hold of me or have any questions related to trenchless or industry or anything like that, I'd be more than happy to help you out and answer anything like that. So with that, I'd like to thank you very much, and I'm going to.
Thank you, Sam. Sorry about that. Thank you very much for putting that together today. That was excellent. Thanks for your time. I have to commend you though in terms of your file structure system in your computer must be incredible to be able to find pictures from 20 years ago. So that's great.
I got
so anyways, all right. Thank you, Sam. All right. So that's awesome. So what we're going to do now is we're going to kind of head on with our program. And at this point, I'm going to hand it over to Linda Chaco, and she's going to be the moderator for the remainder of the session. So Linda, over to you.
For sure. Thank you so much. So with our first presentation for the day, we have Chris Lamont. Chris Lamont has over 8 years of experience in civil infrastructure. He might be known to some of you as the knowledgeable, younger, fitter sidekick to Dr. Jason Luke, but he is also known to us in the Edmonton office as the guy who is consistently having a 3-liter bottle of Slurpees with lunch. So here's to present the Thickwood Perimeter direct pipe design, Chris Lamont.
Thank you very much, Linda. Yes, today we're going to talk about the Thickwood storm sewer and direct pipe design and construction that happened in Fort McMurray here over the last year and a half. So today we'll talk about the Thickwood neighborhood, some of the preliminary design that was done. It is a very large project, and this is just one phase of it. We'll go through the Trenchless methodology assessment. We went through various options and came through on the direct pipe as the preferred through a proper assessment. We'll go through some of the direct pipe design process, some of the pre-qualification and tendering that we did, and then we'll just go through some of the construction. So the Thickwood neighborhood is one of the older neighborhoods in Fort McMurray. It was built between 1970 and 1985 during an oil boom. Like I say, this is downtown Fort McMurray, the lower town site, and the Thickwood neighborhood up here, if you can see my mouse moving. It is, like I say, a bit of an older neighborhood, so the design process taken at that time is much different than what we're doing now in terms of weather and things like that. So as the weather and climate change occurs, then the design standards also need to be updated. And this is one of those processes where, due to how the changing weather that's happening, this is an update that needed to happen to this neighborhood. So a rainfall occurred in 2016 where there was quite widespread damage system to flooding. Roads were destroyed. The flows actually collapsed. Certain manholes and roadways were sunk. And so in 2018, A was retained to continue working on this project that to update the storm water and sanitary of this neighborhood. And it was because of the size and age of the neighborhood, it was actually decided to break down this upgrade program into multiple phases. I believe there were in total 7 phases. Right now we're working on phases 2 and 3, I believe, but this was phase 1. Obviously, you have to design from the lower end and build up, or else you don't have anything to push your new system to, and then you create a backlog. So this was in the lower portion of the project. So this is kind of an overall Thickwood neighborhood. This was just one option sheet, but it does show the actual portion of the project we're talking about here today. And this is the outfall, the Athabasca River flowing to the north, the water treatment plant, and large green space, the river valley. And this is where the installation occurred, and basically carries on through the entire neighborhood. So we go through the preliminary design options. Obviously, hydraulic modeling is a big component of the project to make sure that the entire system in the neighborhood works as one. In this case, the various options kind of necessitated a bit of a larger size between a 12 to 1800 diameter. Now that obviously depends on the size and the slope of the pipe. So initially when we were looking at the more conventional open cut with some microtunneling directional drilling, we were on the 1800 diameter. And the sizes did change as we came to a more focused and finalized design. So one of the early options we had was to traverse this unstable slope with a microtunnel. And so we'd microtunnel beneath into the limestone, the clay till, and underneath there's a significant amount of pipelines here, but it did include a significant drop shaft in just over 30 meters. And this was for a 15 to 1800 diameter option. Again, the modeling was still kind of ongoing, and we still didn't have the final diameter just yet, but these were the options and the sizes we were kind of working with. But one of the restrictions that we had was the client, the RMWB, which is understandable, prefers not to use drop shafts, and that's perfectly reasonable, but it does then push us towards a bit of a different option. Sorry, my computer is going backwards here. So in terms of trenchless assessment, when you look at trenchless options, there are various obstacles that you need to almost create a list of. And as we were going through this project, there was quite a list. It includes unstable slopes, staging areas. Sometimes trenchless projects require a decent staging area, and we had to make sure we had that. As we showed before, there were some large diameter pipe options, which increase the complexity, scope, and even just the workspace. The geometry and how the existing right-of-ways and the municipal land worked in this area, there was going to be some alterations, and there were some deflections here in terms of vertical and horizontal alignment we had to work with. And that made it a bit challenging in working with the options that we had going forward. The large difference in elevation in trenchless, typically you're working with slurry pressures, whether it's directional drilling, microtunneling. In general, slurry pressures are quite important to maintain and to manage, and that in a trenchless installation, it requires some finesse for sure. The stratigraphy on its own, we went from clay till to dense sand, cobbles. We went through oil sand deposits and then through limestone. And this limestone varied in strength up to 100 plus MPa in some areas. So this obviously then creates even more complications in terms of machine selection and options and design. Being a storm sewer, on-grade installations, grade criticality needs to be considered. Which trenchless method gives you the grade control you need and can hit the target you need? As I said before, the alignment is quite tight and required certain changes and shifts, and obviously crossing other large diameter oil and gas lines. Grade criticality is very important. And proximity to large water mains, there were 2 large water mains that we paralleled in the workspace. We went beneath, and large water main chambers that we really had to make sure were protected for the continued use of Fort McMurray. So there was a lot of things to consider as we're going through this design. So the list did get quite large. So initially, as I said, we looked at directional drilling. In this case, the diameter, the complex geometry, as well as water quality at this point. Having a trenchless design, an HDD specifically for the diameter we had, there would have been a significant belly underneath here, which in this case with the water line, the elevation as it sits, would have always been full of water. So water quality, as it's going through stagnant water, if there was a long period of time between, would have been a concern. So then looking at the complex geometry with a combined horizontal and vertical curve in the geotech we had was also a large risk. We didn't want to pop out and damage those existing utilities. There is a fiber optic line there, as Sam said, that's pretty high risk sometimes. But then when you look at the 2 large diameter water mains, the risk there was just too high to say we should go this way. Looking at the microtunneling options we had, there were some various deflections and things we had to move. We had to stay back, as I had mentioned before, there was an unstable slope. So our geotechnical consultant provided us kind of some guidance on where we should be in order to avoid those complications and risks. But again, this option was dismissed because of the large drop shaft that was going to be required. So as I said, we developed two options: horizontal directional drilling, microtunneling. Horizontal directional drilling, the tight, complex geometry, the great accuracy, stagnant water, and some of the safety risks that were involved. This progressed a bit further than the microtunneling option, but in the end, it was eliminated. Again, microtunneling eliminated due to the deep drop shaft. So as we were kind of finalizing some of these options, we thought about what about direct pipe? It was an emerging technology. The first installation was completed back in 2007, so it is relatively new. But that's where we decided to start considering this. So direct pipe design, I'll just go through a bit of what direct pipe is. It's a combination of directional drilling and microtunneling. Microtunneling in the sense that it is a microtunnel machine. At the front, it is a Heron Connect proprietary technology. There is another supplier in the US that is making things, but generally associated with a Heron Connect name. But it includes a microtunnel machine at the front, as well as some supporting pumps and slurry systems in the sections behind it. So typically what we'll see with microtunneling, you'll have a microtunnel machine with very few support sections, as they can typically put those pumps and things like that in the pipe behind it. But in this case, direct pipe doesn't allow for that. Like I say, microtunneling, directional drilling, when you directional drill, when you pull the pipe in, you have to, or you do the best you can to have one full string, or to at least have a good length of pipe behind you to limit the amount of joining during the installation. So the directional drilling portion is actually having the entire pipe string laid out and connected behind you. So the diameter, because of the microtunnel machine and the addition of a clamp, as you can see in the picture, what it actually does is the clamp falls over top of the pipe and is secured around it, and it has specialized plates that actually grab to the pipe, and the rams, quite literally, as it's called a thruster, thrusts the microtunnel machine in it advancing along the geometry bore path you need. So to make sure the clamp really is one of the limiting features, but in terms of diameters, you can use between an 800 to a 1500 direct pipe assembly to use. So as I said before, it is a relatively new design or a new technology, and it does not have a design standard. The American Society of Civil Engineers right now is developing a manual of practice, which we're participating in. And so in this case, you rely on those who have done it. They have created quite a few papers in order to assess these calculations. And then we went one step further and had our own assessments done structurally with our structural group to confirm kind of what we had come up with. Direct pipe design, like I said, we use some paper references, but we also use the Pipeline Research Council International. They have an HDD spreadsheet, so we actually modified that to suit kind of what we thought would happen and how the stresses would react. And like I said before, we did use finite element analysis to support the conclusions and calculations that we had been working on. Now, one of the things that Trenchless is very important to assess is it feasible? So, I mean, we can put whatever we want on paper, but it is very important to get a contractor's opinion to make sure what you're doing is feasible. So at the time, there were 2 direct pipe contractors in Canada, and so we did pass this by them to see what they thought was feasible. And so we worked with them. We came up with some various plan profiles and options, And then in the end, we did need to maybe push the envelope a bit more in terms of alignment and grade and complex curves. But it did work out very well for us in the end. So the final design, it is one of the more complex designs with the complex curve. And that's what drove a lot of the structural calculations and making sure that the steel pipe could take the thrusting force. But then even after, when you do these designs, you need to assess not just the installation loads, but also the long-term loading. So the complex stresses involved were all taken into account, which include long-term ground loading, water table, and hydrostatic pressures. So these were all assessed. One of the more interesting parts about this is direct pipe is typically an oil and gas methodology. In this case, this was one of the more interesting requirements for us to have a coating on the inside, which makes it a bit more challenging for the contractor, where as he's preparing this, he is planning where to put slurry pumps. The elevation head makes it quite challenging, so how he protects the pipe during construction is very important. But we did need to maintain a certain water quality to have a lining on the inside. So some of the pre-qualification tendering, we did pre-qualify. As I said, we had advanced the directional drilling option quite a bit further than the microtunneling option, but we did pre-qualify direct pipe as well as horizontal directional drilling, but we only tendered direct pipe. And then once tendered, it was awarded to Sherway Construction and Innovative Pipeline Crossings, IPC. They were the successful contracting team, and construction began in the fall of 2019. So I'll just go through some of the construction. As I said, linings and coatings. One of the big challenges of the project, especially with the temperature as it was starting, you can see the color change. Linings, when they're done in a shop, are one thing, but as you do welding, you need to do field coatings, and you need to make sure they meet the spec for hardness and various pull-out strengths. So those are one of the challenges that we experienced, where the contractor did actually need to heat and hoard some of the pipe to make sure the curing occurred as it needed, to make sure we were getting the quality product we expected for the client. So as the direct pipe equipment started to arrive, obviously having a thruster that can put 500 to 750 tons of force on a pipe requires quite a beefy structure. So what needed to happen was they used screw piles, various 12 and 14-inch diameter screw piles to place in the ground, and then secured their frame on top of that. And then you'll see at the beginning of this installation, they did include a casing pipe. That was to allow them to enter and use a proper slurry seal system, as you can see in the middle here. Direct pipe uses a similar method as it is microtunneling, but it uses a significantly larger annular space, because in difference in microtunneling, direct pipe only has one location where they can lubricate from. Microtunneling, typically you have lubrication ports every 3 to 5, maybe 10 pipe or meters. In this case, there isn't that freedom. You have fins at the back of those microtunnel sections, and that's where the slurry comes out of. So it's very important to maintain that annular space to maintain a good lubrication. So here is the thruster assembly coming to site. Those are quite large. This was a 750-ton system. It was a brand new ordered, and placing everything, you can see all the sections being put together, and a very significant and large and heavy piece of equipment. So as you have these large strings of pipe, you can understand that to get the slurry through them, you would need a significant investment in mechanical pipes, electrical systems. And so these continue through the entire string of the pipe, all the way back to the mud processing system. So on site, they had this set up, and so the slurry would go down these pipes through to the microtunneling system at the front, and then the microtunnel system would chew the ground, digest the material, and it would go back through another return line, and it's processed in this plant. So it comes down goes through the shakers, desanders, desilters, and is processed and then returned back. So all this material is pulled off and the system is recycled to limit the impact and use of water and mud and items like that. But everything has to go through these umbilicals. The communication, all the electronics, pumping power systems. And in this situation, they did have 3 pumps that were inside the pipe. So it was quite a system. As you can see here, this is one of the pipes they're preparing to take down into and get secured in place. That was one of the big challenges on the project, was maintaining the pumps. So MTBM assembly, you can see here actually in this picture, this is where the lubrication ports were on this pipe, and you can see the significant difference and the annular space change, if you will, between the lead tunneling sections and the actual product pipe. And this turned out to be a 1200 diameter steel, 48 inch. And so this is as they're preparing to connect it, they connect it to the existing systems, and this is as we're preparing to launch into the steel casing. And so, sorry, the picture on the left is as they're preparing these sections and getting them in place. So as you can understand, getting everything together in pieces is one thing, but then assembling all the connections is another. So there are some gentlemen there's 3 people in here right now. Sorry, he's the 3rd, there's 2 others. And there isn't a lot of room. So going in there, bolting things, getting everything torqued to hold the pressures is quite a challenge. And one of the problems we had was, as the gentleman was leaving, he accidentally kicked a valve closed. And so that caused a lot of problems because they need to use a crane to lift this steel plate on. So they had to get everyone out, seal it up, and then they found the slurry system wasn't working. So they had to take that plate off, and they just opened it up and found that they had accidentally kicked it. So it can be very finicky, but it does take a lot of preparation time to make work. But it is quite a fast methodology once it's working properly. So you can see his feet, he's just right behind the TBM, getting all the control checks and everything like that. And as the installation progresses, you can understand that all of these lines move with it, and you need to make sure you have enough slack to take the advancement. It is quite a process to manage and make sure you have proper lengths. The grade criticality I mentioned before is very important. And what happened during this installation was we had certain grade tolerances you had to meet in terms of separation from the existing pipelines. And then the elevation at the end was set at plus or minus 30 to 50 mils, I believe. And to do that, you have to actually have survey stoppages where gentlemen go down on what they call the pipe Porsche. And this is a cart that rides on these rails, and they go down and they do this tunnel control check. And I believe they did 2 or 3 of these as they were going, and they would stop and they would send them down. And this operation continued 24 hours a day. So survey was obviously, we ourselves associated, we do tunnel surveying. This is surveying on quite on the next level, very, very confined space. And then once the installation is complete, or once the first installation is complete, in this one we had 2 pipe strings, as you saw in the previous pictures, and you have the golden weld. We couldn't string out all 470 meters at once, so the first installation was complete, and then they moved the second pipe into place, completed the golden weld, and had that prepared. And then the picture in the top right, or sorry, top left, is them actually preparing to take out all of these umbilicals, because as you complete the installation, you still have those 470 meters of all of that infrastructure to pull out. And then the money shot at the end is where the MTBM comes through. And you can see there really isn't much left at the upstream end, which that's kind of what you hope, but there is some extra pipe needed. And you see the MTBM it's been successful. It has taken a bit of wear, but in general, it looks actually quite good. You can see the wearing face on here. Some of the buttons have been removed, but in general, it looks quite good. So in the end, we did have someone do a flyover for us, and this is as the second string was being installed. So just want to thank the RMWB for giving us this opportunity. Jason Luke, Jason Vanderswag, the PM, Mason Ross, who was an associate, is now at the RMWB, Justin Gillard, and Troy McKinnon for support with inspection. Thank you very much. Are there any questions?
So we have a question from Tom Greaves. Chris, how do you mitigate coating damages where the thruster grabs the carrier pipe?
That's one of the first questions pipeline companies ask, actually, is how you or what damage happens. Now, on the first few installations actually completed by Heron Connect, they put stickers around the entire pipe and they pushed it all the way through, and the clamp actually did no damage. They're a special proprietary material that no one but anyone at Heron Connect knows what they're made of. But the clamp itself has been proven that actually does no damage. The way the plates adhere and form around the pipe is it actually causes no damage whatsoever. The pipe will receive more damage going through the geotechnical conditions in the ground than it will from the clamp itself.
Thank you. Anybody else have any questions? And that's just a reminder that you can submit your questions at any time. On the right-hand side, there's a chat, question, poll, and people box. Thanks so much, Chris. That was an awesome presentation. So next up, we have Tom Greaves. Tom is streaming to us from our Calgary office. Tom has over 30 years of experience as a pipeline engineer and project manager. In his free time, Tom likes to show off his pipes by singing in a choir and loves writing as an amateur historian on the World Wars. Please welcome Tom with Alberta Highway Crossing Design.
Okay, well, welcome everybody. This morning we're going to talk about highway utility crossing case histories. There'll be a few puns in here because I know it's not the most interesting project. I know I guess I've dealt with cased crossings for about 30 years, and I've installed them and maintained them and replaced them and try to avoid them whenever I can. So it became a question working on the West Calgary Ring Road. Why, when do you need a casing and when don't you need one? So out of that came this conversation we're going to have this morning. So we're going to talk about, and here the puns are starting already. This is try to keep you awake just before lunch, and there is a quiz at the end. So for all the engineers in the room, you will be marked on it, and we can talk about whether you agree with my answers for everything. So the case for casing, we're going to talk about how implementation, some design requirements, especially to do with Alberta transportation, and then we'll talk about some case studies. Okay, so case cassette, yeah, sorry, couldn't help myself. What is it? So it's a pipe basically encasing the carrier pipe, and the carrier pipe, of course, carries whatever product you want to take across an area. It's it's a couple sizes larger, and the standards will tell you, standards and specs will tell you what size it needs to be, and it's often jointless, and it's often steel, and the carrier pipe has casing spacers, and there'll be some sort of cathodic protection regime required on it, and it's for crossing under an area of concern, and it's often under, actually, I call it 3R engineering: road, railways, or rivers. And I just want to show right now, there's one weak spot, and that's it there, the end seal. And you'll see, we actually exposed 3 casings on the West Calgary Ring Road, and every one of them had water in it. And one of them had so much water, they thought there was a water main break in it. So obviously, some attention needs to be paid there. Okay, so the first case for casings, it's to enable a trenchless crossing across an area that can't be open cut. And the picture up in the upper right-hand corner, that's a road design for the West Calgary Ring Road. This is the Trans-Canada Highway. You can't cross it open cut. The contractor wanted to get across with some electrical conduits, and it had to be trenchlessly. The only problem was where they wanted to do it was this beastie right here, which is sand poorly graded. And what does that look like? And I know some of us are enthralled with geotechnical stuff and some aren't. But so this is why you do a sieve analysis, and you can see this is a well-graded sand, and it means it'll stand up. It won't. It's not like a bunch of marbles. Where this specific sand had this drop off. which meant that if you're trying to use a trenchless option like augering, or Jason or Chris could tell you other methods, the risk of some inadvertent collapse of the soil was very likely, and there'd actually been a struggle east of here to install some stormwater infrastructure as well. So we'd been forewarned, and Craig Pass and I were looking at this and said, let's do some geotech here, and this is what came back. So in this case, it was we need to install some sort of a casing, and we need a trenchless technology that's not going to provide any settlement, because Alberta Transportation said there can be 0 millimeter settlement on the road. This one might be on the quiz, by the way. Okay, and another case for casings is to facilitate pulling the carrier pipe out. So the city of Calgary likes to have that option, and they use it on their water mains quite a lot. Up in Fort McMurray, I was talking to my colleague who's an engineer for Worley Parsons. They also use it when they know that the carrier product is abrasive. So let's say you're carrying something with a lot of sand in it, it's going to erode instead of corrode, and you want to be able to pull it out in the future. So there's a couple times when people do like to put in casings for those reasons. They say that they're going to have to take this thing out at some point in the future. And just if they do use that strategy, just keep in mind that you have to have some laydown area at one end or the other in order to facilitate this. You can't shoehorn this in some area. Okay, so in the case of Alberta Transportation, they use it because they don't want any pipe leakage under their highway. They're focused, of course, on the roadway. And this is just a sketch that Associated has put together that sort of summarizes all the different 4 manuals that Alberta Transportation has on if you're crossing with a power line or a telecommunication line or a gas line, how you should do it. So what they want, if you are using a jointed municipal pipe, like a water pipe, maybe it's PVC or ductile iron, and it has a bell and spigot, you got to put it in a casing. And here's the dimensions you need to use. Here's the lowest depth of cover under the highway that you need to go with. We've also got some power lines on here. They talk a lot about the clear zone. Things have to be pushed back outside the clear zone. That has to do with the velocity of the cars going by, and if they did lose control and go into the ditch, how long it would take them to get back, and what the distance is between the edge of the lane and whatever they don't want to hit, of course. So we use that statement quite a bit. Just an interesting thing, the depth of cover on a water line or any of the other lines, it's not based on, let's say, the frost level that can go down. It's based on the kinetic energy of a vehicle coming off and crashing into, I guess, this ditch, and how long it would take to dissipate that energy. And I just found that out a little while back. Okay, here's a really noisy picture. This one might be on the test too. What we show here is another water line crossing the Trans-Canada Highway. The dotted line shows the existing ground, and what the contractor wants to do is they want to put this big ramp on top of it. They want to pile on about 6.5 meters of cover. So in this case, the casing is there to protect the existing pipe. The existing pipe and the new pipe is going to be jointless, HDPE, but in this case, it's going to have a tremendous load on it. So that load is going to be taken up by this extension of a casing. Okay, so the case against casings. Sorry, there's a pun there. Again, they're quite expensive to install. When they installed casings on the City of Calgary's 900 feeder main at Valley Ridge as part of the West Calgary Ring Road, it added $1 million to the project, that and some other requirements that we needed to do. So they're not cheap, of course. They're hard to maintain, and I just want to thank Steve King for having a chat with me. We had a chat about why the city uses casing sometimes, and so thank you for that, Steve. This is down at Edworthy Park for those who live in Calgary. I don't know if you can notice this, but this is on an angle. Somebody hit that with either a lawnmower or a snowblower or something like that. There's another photo of this in a second. This is for a gas main that goes through there, but you can tell there's a casing there. Someone's nailed it. So these things get hit. It's an ideal place for corrosion to occur. We talked about that on the West Calgary Ring Road. We exposed 3 casings. All 3 of them had water in it. So all 3 of them, their seal systems didn't seem to work, the sealing technology. In oil and gas, a steel casing will mask induced cathodic protection inside the pipe. And that's a concern for them because they like to induce currents on their pipeline. And I finally got to use the word jewelry. The concern is all the jewelry associated with them. So things like vents and cathodic protection, they have to be stored somewhere and they have to daylight somewhere. And this is the City of Calgary's recently relocated pipeline up at Old Banff Coach Road. And it, installed well and everything. The problem is there's going to be equipment through here for the next 2.5, 3 years. And what we've asked for is some Jersey barriers to be put up here because this is just waiting for someone. I've worked on projects where you drive out one day and your nice vent looks like this and no one seems to know what happened to it. And finally, I don't know if you can see it at the bottom of the slide, but it's a mystery. We've had the as-builts. I think Sam talked about that. Usually by the end of a project, the money's run out, so the engineering company doesn't want to spend a lot of time on as-builts. So they don't give you as-builts, they give you as designed. And we had a few surprises actually on the West Calgary Ring Road. Okay, whoops, and here's something I took off the internet. Cased pipe segments could be less safe than uncased segments. Okay, so implementation, really quick. Sorry, this isn't a municipal drawing. This is once again at Edworthy Park, and this is what a cased crossing looks like. All the pipeline companies will have these wooden things up. So when you're done listening to me today, you can drive around your community and you can find these all over the place, and you'll say, "Oh my gosh, that's where a cased crossing is." And thank you, Tom, for showing me that. No, okay, but they have these markers, and they also have, this is the vent, and what they actually are supposed to do is take a pipe wrench and unscrew that and put a dipstick down there and see if there's water in there. And if there's water in there, then the question is, what do you do about it? Okay, but for municipal utilities crossing a highway, if it's PVC, bell and spigot, or ductile iron, bell and spigot, it's got to be within a casing. And the province doesn't allow fusible PVC on their projects. If it's jointed, the casing has to be seamless, and you need the casing spacers and the joint restraint for those bell and spigots. You need the seals, and you need some cathodic protection. And the question is, different folks will talk about, well, what am I designing my CP for? And the province will say for 50 years, and some will say for the life of the pipe. And it's just my concern is how you actually figure out how many anodes you need and where you put them. If it's jointless, you don't need a casing. If it's thick walled, you can go to CSA 662, Z662. It'll tell you what size casing you need. If it's HDPE, DR11, we ran into a problem because most low pressure gas lines are DR17, which are skinnier, and that's the pipe in the background behind me there. That's DR17, so it's got to be one size thicker. And when it comes to stormwater systems, it's the need for a casing isn't applicable. And I just want to stop here for a second because I've seen a couple cases in my career where storm systems have experienced non-plan events, usually where you've got you're draining off a hillside with maybe 20 meters of difference in elevation, and it's draining to a system down in the flats, and you get a hydraulic jump happening. And I don't want to say it's water hammer, it's probably air hammer, where I've seen some damage done to the piping system. So if that happens to be under a highway, maybe you should start the conversation on whether you need a casing for that storm as well. So that would be a third reason, unplanned for operational events. Okay, oil and gas, no open cut. It's quite well laid out in CSA Z662, what you need, the wall thickness, the inner diameter, casing spacers, or you can get away with an uncased heavy wall steel pipe, and that tells you how you figure that out. This is actually down at Edworthy Park in Calgary. That's the railway tracks, that lady standing on the tracks taking a picture. But here's the casing. You can see the little white sign in one end, and it comes all the way to the other end. And I just look at this and say they've never been in there to maintain that one. because there's no damage to the ground. What does Alberta Transportation say? We talked about this. It's got to be DR11 or thicker. Their text. I know, Sam, you have an issue with some spec text. In the original text was DR11 or higher, which someone could argue was DR17, which is actually a thinner wall, of course. So we always like to scrutinize what we're actually asking for. They'll talk about the depth of cover and where you can put your vents. Like they plan for this railway to be expanded, I guess, at some point. Okay. Telecommunication utilities, less scrutiny on those, although talking to Sam and others, these are the guys who, less scrutiny on the installers of these as well. You don't need a casing for them. I just wanted to show this picture of why we insist that telecommunication lines go underground. This is on Sarcee Trail in Calgary, and these street lights, the power between them is shorted out. So instead of installing a new power line underground, they've just gone overhead with it. And it's an aesthetic thing. So on the ring road, you could extend these. Let's assume this is a telecommunication line. You could extend it overhead, but it's an aesthetic thing, especially when you've spent $500 million on something, and then to have this kind of dangly-bangly line going overhead is, they've made the decision that those should go underground. Gets into transmission lines can go overhead, but if they're sharing a pole with a communication line, the communication line has to go underground. Electrical utilities, I've got a better picture now. I apologize. I just really like this one. You're no open cut, of course. Buried lines go in a casing or a conduit. NMAX actually, they actually spent $80,000 to put a steel plate on top of their power lines that are crossing Stony Trail, and the reason was because of all the extra earth moving that was going to happen. They just didn't have they wanted that extra level of confidence to protect their utility. We talked about the clear zone and how far back your poles have to be. This is sort of a rule of thumb. If it's 25 kilovolts and greater, it can go overhead. If it's less than that, it can go underground, but it's very expensive to go underground with high voltage power lines, and street lights are exempt from that. So, okay, we've talked about this cross section before. I won't get into any more detail. This just sort of summarizes the requirements in the 4 documents that Alberta Transportation has, and you can get those on their website. Just some of the requirements, your casing, it has to last for 50 years. So I'd be interested, I'm not a cathodic protection expert, I'd be interested in how someone determines how that's supposed to last 50 years or match the life of the pipeline. Well, what we know now is pipelines are becoming like B-52 bombers. They seem to be able to last forever if you properly maintain them. So there's a little bit of an asterisk there on what it means to match the life of the pipeline. Has to span across the entire highway. I still think we're struggling to find sufficient seals for them. And the vents and signage and all that stuff has to be pushed outside the highway right away. Okay, let's do some case studies and we'll wrap it up real quick. Everybody ready now? Here we go. Okay, so the first one, I may have talked about this. We want to get some electrical and communication infrastructure across the Trans-Canada Highway. They often share what they call joint use crossings and joint use poles and what have you. No settlements allowed. Whoops, look at that, sugar sand, poorly graded. It's not going to hold up as you're moving. Attempt to cross to the east using an auger bore was failed. So here's a cross section. You can see they also want to put a big ramp on it. I don't think I mentioned that, the previous one. The soil's not very good with respect to if you were to just HDD it perhaps without a casing. So do we go casing or no casing? Okay, there we go. So that one was a casing. Hopefully that was straightforward. And if you have any questions about these, just contact me offline and we can have a chat on where our thinking took us to. Case study number 2, we've got a water line. It's jointless, so arguably it does not need a casing to cross the highway, but we need to relocate 70 meters of it at one end because there's going to be a ramp there. and the ramp's going to add 6 meters of fill. So first of all, does it have to be trenchless? I'll just say no, it doesn't, because there's nothing there right now. They can open cut it. And do we need a casing or no casing? Well, here it is. I know the drawing looks a lot the same. Excuse me for the noise. The existing water line goes like this. They're going to raise it up. It's got a big ramp that's going on top of it. So do they need a casing or no casing? And of course, the answer is they needed a casing because of the extra load. The regulations are very adamant that the casing has to take the entire traffic and soil load. You can't adjust some of it to go on the pipe. The City of Calgary also wanted this casing to be a gentle, so that they could pull out the pipe if they ever needed to. So that's where it follows a nice curve here. You can see when they installed the original one, they didn't realize there was a storm sewer right there, and they had to do this dipsy doodle on it. That's talk for another day. Okay, we've got a water line and a sanitary line. They're both jointed PVC. They're cased. They're going to add lanes on each side. Do you extend the casing or not? And the answer, of course, is you extend the casing. Okay, I hope you're at 100% now. Here's an interesting one. It was a water co-op, and they had a 250 steel raw water line. It was built to oil and gas standards. It was welded. We've got to lower it because there's going to be some grade changes on the south side, and we didn't think it had a casing. That's a little hint, or maybe it's a red herring. So do we need a casing or no casing? Keep in mind it's jointless, it's steel, and the answer, of course, is no casing. But then when we got in there, we found out that it actually did have a casing, and that goes back to as-built drawings, but we just plugged off the casing and continued on. Okay, we've got a couple more. This is a storm line, 750, steel. Do we need a casing? How about if it's corrugated steel pipe? How about if it's jointed concrete pipe? It's a storm line. And the answer is no casing. And we talked about, well, maybe you need to scrutinize this more when you've got a huge uphill area draining across the road through a jointed pipe. Case study 6. We've got a PVC one. A developer wants to cross the highway with PVC, he wants to cross it, or maybe HDPE. It depends basically on what they do, and depends on if it's PVC. When it crosses under the road, it needs a casing. Okay, this is the last one, and here's the City of Calgary was relocating its 900 feeder main under the future Stony Trail. It's steel pipe. It's fully welded. But it's pit run gravel soils and it's a shallow bedrock. So do you put in a casing or no casing? And the answer is casing. And that's it for my talk today. I'll throw it back over to you.